Hi everyone. So I think everyone's stressing out for the Edexcel A-level paper 2 tomorrow. Um, and one thing that I think people have said is that there were no parametric equations on paper 1, which means there's going to be at least one tricky parametric equation question on paper 2 tomorrow. And probably two, let's face it, because it's a big topic. But I think towards the end of the paper, there's probably going to be a high marker on parametric integration. So that's what I'm going to go through in this video. I've got two questions here. I've got a slightly nicer question. With parametrics, you can pretty much divide it into the nicer questions where there's just algebra, or maybe you have a rogue logarithm or an exponential. And then you have the trickier ones, which are anything really involving trig. Okay, and so I'm going to go through the nicer question first. Okay, so yeah, looking here, we've got x in terms of t, y in terms of t. Part A, just a one marker saying what's the domain. A lot of people hate those domain and range questions. But if we look here, so domain and values of x. So domain is the possible options for what x can be. X is a Lin graph and t is bigger than -2/3. So Lin is quite a nice graph because it just keeps going up, which means if we sub in t, not sure where this is going to be, but say it's here, -2/3. If we sub this in here, x is just going to be everything bigger than that. Okay, so we just sub in the -2/3, so x is going to be everything bigger than ln of -2/3 plus 2, which is ln of 4/3. X has to be bigger than ln 4/3. There's no nice way to simplify that, and it's just going to be some weird decimal if we put it in the calculator, so we can just give our answer as ln 4/3. So that was just a trick we could do. We could just sub that in just because ln is always going up. So if we find out the starting point, it's going to be just everything bigger than that. So let's get rid of this and then look at the main topic, which is the parametric integration. And you can see this is where all the marks are. So firstly, we need the formula for parametric integration, which is not in the formula book. So you do have to know this off by heart. So that's the integral of, instead of just the typical integrate the equation of y with respect to x, for parametrics we do the integral of y, but we do dx dt, and then we're integrating this with respect to t. Okay, so because this says dt with respect to t, that means when we do our integral, all of this needs to be in terms of t. Okay, so the y part, that's really straightforward because we know y in terms of t, so we're just going to sub that in. And then dx dt, we know x is ln of t plus 2. So that means that dx dt is, we've got a minor chain rule there. So ln goes to 1 over, so 1 over t plus 2, times by the derivative of whatever's inside the brackets, which is just 1. So no effect here, so it's just 1 over t plus 2. Okay, so our integral of y times dx dt is 1 over t plus 1 times 1 over t plus 2 dt. And we'll just put this together, so it's 1 over t plus 1, t plus 2 dt. And we're not just doing some random integral here, we're finding the area on the graph, so that means we need to put our limits in. Okay, and we can see from the graph the limits are x is ln 2 and x is ln 4. But in our integral, we have a dt, so our limit should be what t is, not what x is. Okay, so we need to find t, we have x, so all we need to do is sub our x's into this and rearrange to find t. So we're going to have, when x is ln 2, it means x is ln t plus 2. You could solve this, but also you can kind of just see from here, if it needs to be 2 inside the brackets, then t is going to have to be 0. So we've got our lower limit is 0. Okay, and then for ln 4, we can see again, that's ln t plus 2. You can rearrange, but just comparing ln of 4 and ln of t plus 2, t is going to have to be 2. Okay, so it's our integral from 0 to 2. And now we've done all of the parametric stuff here. We just have now an integral. We just need to figure out how to integrate this. A lot of people here, I think, would say, oh, could it be reverse chain rule because you have kind of brackets on the bottom? But remember, for reverse chain rule, you need to have the derivative of the bottom on the top. And because this is a quadratic, the derivative is going to be something like 2t plus 3 or some kind of linear function on the top, which we don't have. We just have a 1, okay, which only leaves one other option. That's got to be partial fractions. Okay, so we're going to work that out first of all. 1 over t plus 1 times t plus 2 is a over t plus 1 plus b over t plus 2. Now we've got to go through this whole monotonous method that I think everyone's done a million times at this point. So a times t plus 2 plus b times t plus 1 is 1. Substitute in your values, t equals minus 2. Not really going to explain this method because it's not a partial fractions video. So sub that in, sub in minus 2, this disappears. So minus 2 plus 1 is minus 1b equals 1, leaving b equals minus 1. Underline that in red for later. And then make this part disappear. That means t needs to be minus 1. So a is 1. Okay, that's quite nice. And then we've got our partial fractions here. We just write these in. And remember, we're integrating from 0 up to 2 of 1 over t plus 1 minus 1 over t plus 2 dt. Now looking at these, we can see, okay, on the bottom of the fraction, you just have a linear function. The derivative is just a number, and that's what we have on the top. So we can just do reverse chain rule here. So 1 over something, that's going to be a ln function. And then check, when you differentiate this, do you get the constant on the top? You get 1 over t plus 1 times by the derivative of the inside with the chain rule, which is just 1. So this would differentiate exactly to this. So we don't need to kind of adjust the constant here at all. Looking at this, we've got 1 over t plus 2, again with reverse chain rule, that's going to be a ln. If we differentiate this, we're going to get 1 over t plus 2, and we just need a minus. So we need to just put a minus in front there. Now we've done our integration. We're on easy street now. We just need to sub in the limits. Ln of 2 plus 1 is 3. Ln of 2 plus 2 is 4. Take away your lower limit. Ln of 1, that's 0. I'll just cross that out here. Ln of 0 plus 2 is ln of 2. Expand. So much expanding and simplifying in A-level maths. And then let's look at what they're asking for. They're probably asking for a single logarithm. Yeah, they love this. So we're just going to put these together. So if logs are adding, you can multiply them. And then if you're subtracting, you divide. Simplify this. 6 over 4 ln 3 over 2. And that's your answer. Okay, so a lot of work there. There's a lot of steps, kind of a lot of things coming into that. But you can turn it into a normal integration problem pretty quickly. You just really need to remember this formula, differentiate and sub in, and then you're just left with a standard integral problem. Okay, let's move on to the integration with trig parametric questions. So here we need to find the integral under the graph. We need to find the area under the graph. And the issue is we have x and y in terms of t, but these are both trig functions. So we're expecting this to just be a bit longer and probably to involve some trig identities here as well. Okay, but we start off the exact same way. So the area is given by y times dx dt. So we need y, we know it's 5 sine 2t. 5 sine 2t times by the derivative of x. X is 6 sine t. Okay, so the derivative will be 6 cos t. So we're going to times by this. And then simplify. 5 times 6 is 30. Cos t sine 2t. Let's kind of swap that around for some reason, not sure why. And then we just need our limits here. You can see from what they've done, the limits for t have gone from 0 to pi over 2. You do need to be a bit careful there because yeah, you do need to be a bit careful there because sometimes these aren't in the same order. So if this was something this wouldn't necessarily correspond to t as pi over 2, and this wouldn't necessarily correspond to t as 0. So you would check that first. So these are where y equals 0. So solve that. 5 sine 2t equals 0. Sine 2t is 0. Solve this. If sine is 0, then that's going to be 2t is 0, or pi, and so on, until you get out of your range. So t is 0, pi over 2, and then sub them into here. So that would make when t is 0, x is 0. When t is pi over 2, x is 6. So we can see, yeah, in this case, they do correspond to the right order. If t is pi over 2, you get the upper limit. So we can say t is pi over 2 at the top and 0 at the bottom. I'm going to make some room here. Now we've got an integral. Looking at what they're asking for, they have no 2t, they have no double angle in here. So we need to get rid of this. Of course, sine 2t, if we want to turn it into to be in terms of t, we need to use the double angle formula. Okay, so sine 2t is, so we'll put this in, times by the double angle formula for sine, which is, we know this off by heart, 2 sine t cos t, 0 pi over 2. And then we just simplify 60 sine t. And we've got a repeated term here, cos t times cos t, so cos squared of t dt, 0 pi over 2. And this matches up to what they've done. A lot of work for just 3 marks there, but hopefully the marks are easier to get later on in the question. Hence show by algebraic integration the area of R is exactly 20. Okay, so we just need to do this integral. And this does throw people off. You have a trig integral here. And the trick is, if you have a trig integral, you're looking at this and you're thinking, not really sure where to go with that. Take any power of the trig and move it out into a bracket. So 60 sine t, I'm going to make this cos t all squared. And that's just because if you do that and then you look at that, it kind of makes more sense in your mind. And you think, oh, okay, we've got a bracket squared here. We've got the derivative roughly on the outside. I'm going to do reverse chain rule. Okay, so once we've decided we're doing reverse chain rule, we take our bracket, add 1 to the power, and then we think, what would this differentiate to? So if we just try to differentiate this, we would get 3 cos t squared from the chain rule times by the derivative of the inside, which is minus sine t. So we would get minus 3 sine t cos t squared if we try to differentiate this normally. So we don't want minus 3, we want 60. So we need to times this by minus 20. Yeah, and that means that this would differentiate exactly to this. So that's our integral. So that's completed. And then put the limits in, pi over 2 and 0. And now we're on easy street. We just need to sub the limits in. Minus 20 cos pi over 2 cubed minus 20 cos 0 cubed. These are both exact values. Cos pi over 2 is 0, so that all goes. Minus minus goes to a plus. 20 times cos of 0 is 1, so we just have 20 times 1 cubed, which is just 20. So that's our final answer. Yeah, so you can see just a lot trickier just because instead of algebra in the parametric equations, you have trig. That's added so much work and pain. But looking on to part B, part of the curve. Okay, so that's really going on to one of these like Edexcel kind of problem solving questions. That's not really to do with just the standard parametric integration. So I'll leave you all to struggle with that, and good luck on the exam tomorrow.